So today we are joined by Alice Bruemmer. Alice is from Monterey, California, and received her Bachelor of Science in Science Business at the University of Notre Dame, and has just completed her master's degree in Marine Science and Climate Change at the University of Gibraltar. She hopes to make changes in the world of ocean conservation through reduction of litter, especially single-use plastics. So without any further delay, I will hand you over to today's speaker. Alice, off you go.
Thank you so much. Hello, everybody. Thank you for joining my talk today. I'm really excited to share my research with you all. As mentioned, I just completed a master's degree at the University of Gibraltar in Marine Science and Climate Change. So today I will be presenting the research project that I conducted for my thesis. The study topic of my thesis was marine litter, and specifically the interactions that marine litter has with fauna in the marine environment, and then even more specifically, those interactions in submarine canyons. So I'll go ahead and share my presentation now. As a quick disclaimer, I'm currently working on a farm in Spain, and my Wi-Fi connection is normally great, but sometimes a little iffy. So I'm going to turn off my video while I present. Okay, so as you can tell, I had some fun creating the name for this project, the ALICE project. It is the assessment of marine litter-fauna interactions in submarine canyon environments. Today, I will start off with some background of the issue, then move into the methods that I use to conduct this research project. I'll go through the results both of the literature review and my data analysis, and then discuss a little bit about the significance. So starting off with the background, first off, what is marine litter? As a lot of us already know, marine litter it's man-made solid material that ends up in the ocean, either by being disposed there or on accident. My research focused on marine macro litter, which is defined as being over 5 millimeters in length. So when I talk about litter, I'm talking about macro litter. Unfortunately, marine litter is ubiquitous in the ocean today. It comes mostly from land through avenues like landfills and river transport and coastal activities. Marine litter travels through the ocean via currents and eventually sinks and largely winds up on the deep sea floor and in submarine canyons. Plastic is the most prevalent marine litter material. It makes up to 95% of marine litter, and included within that plastic category is a lot of synthetic fishing gear, which can be really, really prevalent, and it especially gets snagged on jagged features. In general, marine litter degrades very slowly, but in the deep sea and in those submarine canyons, that degradation is even slower due to the lack of UV light, how cold it is down there, and also low oxygen content. So submarine canyons is where I focus my research on. So a submarine canyon is a complex topographical feature. A canyon is incised into the continental shelf, and submarine canyons are considered keystone structures because they provide habitat heterogeneity, so lots of different species live within them. In this figure, you see a diagram of a canyon with just some of the terminology that I will be using today. So canyons, at the top is the head, and then that comes down onto the canyon floor. The flanks are the steep sides, and then the interfluves are those higher sections on the side in between different submarine canyons. The hydrodynamics of submarine canyons transport sediment from the canyon head down to the floor, and that can bring any litter as well along down with that sediment. And so that actually results in the highest density of marine litter is found in submarine canyons. Down there are a lot of deep sea species, like I mentioned, due to the habitat heterogeneity, and these species grow really slowly, and so they can be especially vulnerable to pressures, such as those from the marine litter. Unfortunately, submarine canyons are difficult to study due to just the logistics of getting down there and also any costs incurred in that. So specifically, my study site was the Canyons Marine Conservation Zone, or MCZ, which is a marine protected area in UK offshore waters. You can see on the left image, the purple box is the Canyons MCZ, just to the southwest of England. This was designated in 2013, and on the right, you see the two canyons that are within it. So the Explorer Canyon at the top, and then the Danguard Canyon below. This MCZ contains 4 features or habitats of conservation importance. So first of all, cold water coral reefs. Actually, the only ones in English offshore waters are within the Canyons MCZ. There's deep seabed as well, coral gardens, which is multiple different types of coral that provide lots of habitat, and then sea pen and burrowing megafauna communities. Within the Canyons MCZ, the main type of litter seen is fishing gear. So there's a lot of monofilament fishing line and also rope. And the types of litter within the canyons was analyzed by Ivan Hernandez, who was also a student at the University of Gibraltar, and he completed his thesis in 2020 and analyzed the types of litter found. And he found that the types of litter within the canyons really differs from coastal canyons just because they're offshore. And so it's a lot more fishing gear rather than more, general like household litter and things like that. So now moving on to the marine litter-fauna interactions. So this was the main focus of my project. Litter-fauna interactions, mostly ingestion and entanglement occur. So this is when litter, when it travels through the currents and then ends up on the seafloor, it interacts with fauna through that process and that transport. So mostly ingestion and entanglement are noted, but there also are other types of interactions, which I will be getting to later on. But in general, this field of research has a lot of gaps in it. So there's just a general lack of research. Any reporting of marine litter fauna interactions most generally is happening if a research team is looking for one thing and they happen to find these interactions happening, and so there's unstandardized reporting. There are some frameworks of interactions that have been used, but like I said, no standardized one. And so that makes global comparison pretty difficult. And also the impacts of these interactions are really unquantified. They're sporadically quantified on the individual level, but not on the ecosystem level. So my research project had 4 objectives. First was to just assess the current state of research of litter-fauna interactions, and then to create a standardized reporting framework for those interactions, then to measure the interactions occurring within the canyons, and to suggest the impacts of litter-fauna interactions on the canyons. So jumping into the methods for how I completed this research project, I had 2 steps. So the first was a critical literature review. I used a Google Scholar keyword search, and I was looking for interactions, and then specifically those primary litter fauna interactions occurring within submarine canyons. And then I completed data analysis on the Canyons MCZ using BIIGLE, which is a web-based photo and video annotation software I think some of you are familiar with. On the left side, you can see the map of, so I had 2 different surveys that I used from 2015 and 2017. So on the left side is the map from the 2015 survey, which was the footage was provided by the National Oceanographic Center. And that survey focused on cold water corals on the flanks of the Explorer Canyon. So those 2 circles are where the surveys took place, and that was using an ROV. So any litter that was also filmed and photographed in that, I was analyzing. And then in 2017, JNCC, you guys did an assessment more in the inner fluves, and that is depicted in the right image. So all of those red dots are where photos and images, or photos, and videos were taken. And that was with a towed camera. So I used, in my analysis on BIIGLE, I used the photos because litter was really hard to see in the videos. So in fact, in places where there was a photo and a video taken of the same area, oftentimes you could see the litter in the photo, but not in the video. So I ended up just using the photos for analysis. So jumping into the results of my literature review, I will talk about the framework that I created for the interactions, and then the impacts of those interactions that have been reported and discussed, and then finally the reports of primary reports of interactions occurring within submarine canyons. So starting off, here is the litter-fauna interactions framework. I'm going to go into more detail on each of these with specific images, but I just wanted to show this as this is the framework with the 6 types of interactions and then common examples or synonyms. So those 6 interactions are entanglement, ingestion, smothering, habitat provision, adaptive behavior, and encountering. This all comes from the literature review of the papers that mentioned litter-fauna interactions, and so it's summarized here into this consistent standard framework that can be used for reporting in the future. All of these are interactions with fauna, but then also there are some abiotic interactions that occur, and that is entanglement and smothering. So now I'll go through some examples of each of the 6 types. So first of all, entanglement. This is when fauna is ensnared and becomes stuck within a piece of litter. It can either remain mobile with the litter just being attached, or it can become immobilized by the litter. So starting on the top row on that left side, you see an urchin with rope wrapped around it and entangled in it. In the middle, you see a fishing net around cold water corals. So this is called coral snagging. And then on the right side, you also see there's a plastic bag on that coral. So this coral snagging is pretty impactful. So it abrades the tissues of the coral and results in necrosis, and oftentimes can result in death. On the bottom row, starting on the left, that's a mola mola trapped in a fishing pot. In the middle, this is a net just around an abiotic, just around a rock. So abiotic entanglement can degrade and alter and even obstruct some habitats. And then on the right side, you see crabs stuck in a fishing net. So this is another subset of entanglement called ghost fishing. And that's when fishing gear that's been lost and is no longer controlled by the fishermen ends up still catching different fauna. And this actually, so this is an example. These crabs are stuck in this net, and then something that can then happen after this is called self-baiting ghost fishing, which I learned about through this project, and it's my least favorite thing in the world. It's when these animals are getting stuck in ghost fishing gear, and then they die, and a scavenger comes along to eat them, and then it gets stuck as well and dies, and the cycle just kind of continues. So ghost fishing can be really dangerous. Next is ingestion. So this obviously is when litter is eaten, whether on purpose, if it looks more like prey, or on accident, if the prey had some litter in its stomach, or by filter feeders filtering in microplastics and stuff. These images, so at the top you see a turtle that has kind of ingested and gotten stuck with this fishing hook. And then on the bottom row, there's a porpoise on the left that's ingested and it's got this bracelet stuck in its mouth. And then on the right, there's a bottle cap stuck in the turtle's mouth. This is a little harder to see on video, and these are images with macro litter, but a lot of times ingestion occurs with micro litter. So it's not yet that I've seen been reported in canyons on video or on photos, but there are still lots of impacts from ingestion, like blocking the throat or the digestion of the species. It can cause internal injuries and also potentially leak toxins, and then end up spreading the toxins and also the litter kind of up the food chain. So the next interaction, which, as I mentioned, can be biotic or abiotic, is smothering. So this is when litter, mostly wider pieces of litter, settle on top of fauna or the seafloor, and it blocks the water flow. In this top image, you see a bag that's ironically labeled biodegradable, and it is smothering some corals. And then in the bottom row, you see some plastic bags and then a mattress smothering the seafloor. This is the abiotic version of smothering, which ends up homogenizing habitats, and it creates anoxic mud and can interfere just generally with the sediment water flux. And then the biotic impacts are just blocking food for the species that have been smothered, and then also suffocating them. Now moving on to habitat provision. Habitat provision happens both in substrate provision and shelter provision, but I've grouped them into this one main category. Substrate provision, as you see in the top left with those species encrusting the old barrel, this is when species grow on litter instead of their natural materials. So in the bottom right as well, you can see these corals growing on a fishing line. And unfortunately, this can cause dispersion. So when the litter is dispersed that has creatures growing on it, that can actually bring new species to places, including invasive species. So that can be dangerous and, adjust the carrying capacities and increase competition of habitats. And then the other half of habitat provision is shelter provision. So you see in the top right, and then the bottom left has both shelter and substrate. But you can see these fish in both examples just kind of within the pieces of litter. And then that also has the impact of just missing the better alternative. So both of these examples are species are choosing to settle in or on litter instead of a potential natural material that could be better for them. Adaptive behavior is the next type of interaction. You can see here this crab is carrying a piece of plastic. So this is when species adapt to the presence of litter in ways other than just general habitat provision. So carrying, other examples are egg laying, used as an egg laying substrate and then also as an aggregation site. And this generally alters natural systems and behavior with pretty unquantified effects. So this is actually the least studied of all of the types of interactions that I found. And then finally, the sixth type of interaction is encountering. So this is when a species comes across litter, but there's no interaction in the 5 ways that I just listed. These pictures depict, so on the left side, you can see an anemone. It's near this piece of rope. In the middle, a fish is swimming toward a snag of fishing line. And then on the right side, those are anemones kind of touching this piece of rope. So examples of encountering are touching and collision, which can cause wounds. And then as shown in the picture on the left, this is what's considered non-contact encountering. So when a species is within 2 of its own body lengths of a piece of litter, there's increased likelihood of the other interactions and also potential for dangers due to toxins leaching. It's in order to not like conflate the data, it can't be listed as something that it's not. So if a species looks like it's entangled in a piece of litter, but we can't quite be sure, we can call it encountering. So encountering kind of ends up being this catch-all term, but it's important to still note and report that that these interactions are occurring or they're likely to occur with the non-contact encountering. So I created, again, through my literature review, a big table that connects all of the interactions that I read about to the different impacts that are possible. So this chord diagram on the right shows the biotic impacts of the interaction. So the 6 interactions are bolded, and then all of the primary impacts are listed in non-bold. And this chord diagram just shows how the different interactions are overlapping in their impacts. And you can see that entanglement and smothering have the most different types of impacts. And then this is the same type of chord diagram showing the overlap between the abiotic interactions and their impacts, entanglement and smothering. And as you can see, smothering has the most number of impacts. So from the literature review, I found 21 papers that had primary data on litter-fauna interactions within submarine canyons. They're listed all here, so the dots show those 21 papers, and there is looks like a bias, likely a reporting bias, it's just in the northern hemisphere, and you can see here that 17 out of the 21 reports were done in the Mediterranean than just outside. We know that there are more canyons all around the world, so it's likely that it's not just that there's more litter in these spots, but this is a reporting bias. Within those 21 papers, the most reported litter type that is seen interacting with species in submarine canyons is plastic. The most common phyla seen interacting is Cnidarians, which includes corals, anemones, and true jellies. And then the most common interaction types were both entanglement and habitat provision. Zooming in a little bit on the Cnidarian orders, if we take a closer look, the orders of Cnidarian that are interacting the most with litter are Scleractinians, which are stony corals, and Alcyonians, which are soft corals. And as I mentioned previously, coral snagging, which is a subset of entanglement, can be very damaging. So this was interesting to see that there has been, out of the reports that we have, there's been a lot of coral interaction that we've seen. So now jumping into my data analysis results. I analyzed 585 images, and there were about 1,500 interactions were observed in those. 60% of the images had interactions. So every image had a piece of litter, and 60% of those had interactions, and then 40% had no interactions. So in these images, you can see in the left, there's a wrapper kind of smothering on the top left, and then in the middle, this is rope entangled in corals. On the right side, this is fishing line entangled in urchins, and then also some corals. And as you can tell, it's a little hard to see, but there is a fishing line crossing through there. The bottom left, there's a plastic bag smothering. And then in the middle, this is a conglomeration of, it's a rope with some hydroids growing on it, and there are anemones in there, both being entangled and living on the rope. And then in the bottom right corner, this was often seen as just a rope with some hydroids growing on it. So the most common interaction types that I've seen, so this diagram shows on the right side, we've got all the different types of interactions, and then this donut graph just shows how often I saw them within all of those images. So about 75% of the interactions were encountering. As you can tell here, the greenish blue color is no interaction. So if we remove that out of all of the interactions, encountering is about 75%. Of those interactions, about 60% were non-contact, and about 40% were with the litter being in contact with the fauna. And then, as I mentioned earlier about encountering, it's a little bit of a catch-all. So it's possible that some of those interactions were actually entanglement or habitat provision, but where I couldn't be sure when I was analyzing the images, I would just mark it down as encountering because I didn't want to conflate the data and say that there's more entanglement than is actually happening. But I did want to be sure that that I was recording that these interactions are occurring. So then jumping in, this is the same type of graph, just showing the most common phyla that were affected in the two surveys that I was looking at within the Canyons MCZ. So about 3/4 of that were cnidarians, and then that, the prevalence of cnidarians also lines up with what I found in the 21 reports of primary interactions. By order within cnidarians, the Cnidaria were the most common, especially actinose richardii anemones, and then scleractinians and hydrozoans, and then also just unspecified dead corals. The most common litter types, again, this is that same type of graph just showing how often I was seeing various types of litter. So plastic was the most prevalent. Out of all of this, it was mostly fishing gear. So 95% of total litter was fishing gear, both plastic and then rope, which is the gray. It's labeled as miscellaneous here. And that obviously lines up with what Ivan had found when he assessed the canyons for general types of litter. So this graph shows the most common combinations of taxa with the interaction that are occurring within the Canyons MCZ. So on the y-axis, we see the 3 most common combinations, which are Madrepora oculata, which is a scleractinian coral encountering, dead coral encountering, and then Madrepora oculata again entangled in litter. And then on the x-axis, it's just the number of observations that I counted. As a reminder, this 2015, the 2015 data, they were looking at the flanks of the Explorer Canyon. So in that, the initial graph that I had showed with the 2 circles of where this survey focused, it was looking at the flanks of the Explorer Canyon and specifically looking for cold water corals. And so there's, bias in the prevalence of the amount of cold water corals that we're seeing here, but at the same time, we're still seeing that this is occurring. So even though there was a bias in where the survey was looking, we're still finding this encountering and this entanglement. For the Madrepora oculata encountering, about 3/4 of that was contact encountering with the litter, so touching. So again, potentially entanglement, but where I couldn't be sure, I just listed it down as contact encountering. And then dead corals were just over 90% of those were in contact with the litter. So there's a lot of contact. between corals and litter, which is, as I mentioned previously, can be very damaging, can hurt the tissues, and then lead to necrosis and death. In 2017, so this study was largely looking at the interfluves. So again, on the y-axis, we see the three most common taxa-interaction combinations. So Actinose richardii, that anemone was encountering, and then hydroids. There were a lot of hydroids growing on rope within the 2017 data, and then Cnidaria, just general anemones, were encountering as well. For both the Actinose richardii and the Cnidaria encountering, about 65% of that was actually non-contact. So there was more of it just being within 2 body lengths than actually touching the litter. And with the 2015 and the 2017, all 6 of these the pairings included Cnidarians. So Cnidarians were very commonly seen interacting with litter here, which is, just what I saw within those 21, the primary reports, as I said. So now jumping into the significance of the research. First of all, like I had said, I had some objectives of kind of filling some of the gaps that we have in Litter-Fauna Interactions study. So far, only 21 papers report primary data from interactions within canyons. This research has just, added a little bit more to that, so that helps with quantification. Non-standardized reporting, we're generally seeing non-standardized reporting. So the fact that I created that, the framework, the standardized framework, can help fill that gap and help, hopefully, if that's able to start being used, that framework can help with global comparison and kind of just seeing what the global trends are with different types of interactions that are occurring. And then so we know that these interactions are causing impacts. Impacts are difficult to quantify and have yet to be really quantified, like I said. So that's going to just keep requiring continued research. I did create those, the core diagrams, and I have the bigger framework that shows the impacts that result from interactions, but that will just require more monitoring to see how often those are happening. However, I do think it's we know that impacts are occurring. We know that these interactions are occurring. So even if we don't know the exact connections and the strength of those impacts per se, I think it's important to keep trying to reduce impacts at the same time as we research the extent. All right, so just a little bit about a little discussion about what I saw within the canyons. From the literature review, we know that coral entanglement in fishing gear was the most commonly reported interaction happening in submarine canyons. And in the 2015 data, both contact encountering and entanglement were very often seen with cold water corals. This picture is, if you look closely, you can see there's just a mess of monofilament fishing line within those corals. As I mentioned a little earlier, it is key to point out that the 2015 footage was searching for corals. So there's a bias in the amount that's seen compared to other things, but we still know that it's happening. We still know that corals are can be very damaged by contact with litter. So it was important to find that this is occurring within the canyons. And like I mentioned, some of the impacts that this can have could potentially be diseases, necrosis, death. Cold water corals grow really slowly, and so there's a potential for further ecosystem impacts if the corals are really damaged by all of this litter. And then in the right side, this is from the 2017 footage. This is an example of some of the most common interactions seen. So you can see there's an anemone growing on a rock, and it's got a piece of rope kind of wrapped around it and touching the anemone. And then on that rope, there are a lot of hydroids growing. So the anemones are actually probably likely unaffected. That's my current thinking. They're pretty robust. And the hydroids, invasives, are a problem. I'm not sure if these are invasive or not, if they came in already growing on the rope or if they started growing from there, so I can't quite speak to that. But it's more likely that the damage from the cold water corals is more impactful than from the anemones just kind of touching or being near the litter. So for the 4 features of conservation importance within the Canyons MCZ, which as a reminder, those are cold water corals, deep seabed, coral gardens, and then sea pen and burrowing megafauna communities. So within the Canyons JNCC, you guys have assessed the pressures exerted due to human activities. One pressure due to the activity of fishing is litter. The deep sea bed has been assessed to be sensitive to litter, but the other 3 features are unassessed at this point. So I went ahead and created sensitivity and vulnerability assessments for the pressure of litter. So for sensitivity, I was looking at the likely tolerance of those features to the pressure of litter. And then vulnerability, I took more into account the specifics of the site, so the exposure of those specific features to the litter present in the canyons based on what I was seeing in the images. And this is what I created. I know it's a little fuzzy, and you don't need to read through it. I'm going to get into the key points, but I just wanted to show you what I created. So this is the sensitivity table. So starting on the left, we see, so the activity that I was assessing was fishing. The pressure was litter, and then I went in and I created sub pressures from the pressure of litter, and those sub-pressures are the primary impacts that I showed previously in the chord diagrams that I pulled from the literature review of what is happening when litter interacts with species. And so then in the colored section, we see the 4 different features of conservation importance, and then I have whether they're, I've assessed whether they're sensitive, not sensitive, unknown, or generally not relevant. So that's the sensitivity assessment. And then I've done the same thing with the vulnerability assessment. So it's all the same, except again, this was more site specific. And so the darker the orange, the higher the vulnerability of that specific feature to the sub-pressure of litter. So these are the takeaways. So I combined looking at the sensitivity assessment and the vulnerability assessment. These are the overlaps between things that are both sensitive and highly vulnerable within the Canyons MCZ. So in general, the natural system is just being modified by the presence of litter and by any interactions that are occurring. This happens in all 4 of the features with potentially harmful impacts, largely, fairly unknown in the specific area what those specific impacts are, but there's potential for strong impacts. And then also, as you see below, so cold water corals and coral gardens are very sensitive and highly vulnerable to breaking or wounds, and then also death from the presence of litter. Like I've mentioned a couple times, corals are damaged, their tissues are damaged, and they can die from just being in contact with litter. And so that seems to me like the biggest threat to the Canyons MCZ. Like I said earlier, the only cold water corals are found within English waters are on the flank of the Explorer Canyon. So that's, potentially damaging. I think even without this uniqueness, it's still, these corals are providing valuable habitat, but it is interesting to note that the only corals in English waters do have all of this fishing gear kind of in them that I've seen. Corals, just a couple of interesting points about how corals really are damaged by litter. A study by Lamb et al. In 2018 found it was in the Asia Pacific, so tropical corals there had a 4% chance of contracting diseases just in general. But when plastic was introduced to the environment, that likelihood went up to 89%. And then a study by Chaperone et al. In 2018 found that Lophelia pertusa, which is another scleractinian coral that's found within the Explorer Canyon, that had, when plastic was introduced, the Lophelia pertusa had significantly reduced skeletal growth and also difficulties in prey capture due to that plastic smothering it. So cold water corals grow really slowly. Like I mentioned, they grow only about 5 millimeters a year, and they can live up to 8,000 years, but with this very slow growth. So they might be more susceptible to the impacts than even those faster growing tropical corals that have been assessed. So I've assessed this data. Like I said, I've got the one survey that I looked at was from 2015 and the other one was from 2017. So it could be interesting to have a more recent update to see how the litter has, accumulated or what has changed within those specific locations within the canyons, and kind of see if any impacts have started to set in that we can see. So yeah, I think, potentially updated surveys could be very interesting to kind of test the likelihood of those impacts occurring over a set period of time. So to kind of wrap things up, what can be done with this issue of litter in the ocean interacting with different fauna? There are kind of two schools of thought on this. So you can clean up what exists, or you can prevent new addition. In general, litter is this really big issue because our consumption habits and processes as humans are pretty unsustainable. It's linear, so things are produced and then they're consumed and then they're discarded, and oftentimes they're not reused. There can be a very big disconnect between a person who's using a product and then where that ends up being disposed of. And at the same time, the producers really have very low responsibility for what ends up happening with their packaging or their goods as well. So I kind of seems to me like we're kind of running this giant experiment to see what happens when too much litter ends up in the ocean and ends up interacting with these species. So this first school of thought, like I mentioned, is to just clean up what exists, which is pretty popular, especially, I feel like everyone's probably done a beach cleanup at least once in their life. It's a feel-good activity, but it's very obviously location specific. It's pretty much impossible in canyons at this point, and it can actually end up removing or disturbing habitat and species that have had to adapt to the presence of the litter. And so, if you're removing a piece of litter that has a species growing on it, you're actually potentially damaging that species more than if you had just let the litter stay. So it's likely that this preventing new addition is going to be the way that we actually tackle this issue. That can have these global effects because litter is transported throughout currents all over the ocean. So if we're preventing new addition, that can cause big impacts. Unfortunately, it's expensive and it's very difficult to promote just because we're all so used to our day-to-day consumption habits. But likely this is the way that we do it. We can especially target the most harmful pieces. So potentially, like within the Canyons MCZ, we know that the fishing gear, especially the monofilament fishing line, can be damaging to the corals. So specific site-specific bans on the use of those materials could potentially help. And then also just continued research, I think, is important on the impacts of litter. And like I was saying earlier, with looking at one location one year and then rechecking that same location year after year to see how long it's taking for any impacts to occur. That combined with some like targeted scientific communication to help engage the public. I think these are all very important things that we kind of need to push for right now. Because we know that these interactions are occurring. It seems, there are impacts as well that just are largely unquantified. So at the same time as we quantify them, I think it's important that we work on stopping, new input of litter and new impacts from happening. So just as a wrap up, so the next steps of the Alice project, first of all, I'm going to be publishing the literature review that I completed for this project, and then the standardized framework that I created is going to be shared with the UN Litter Working Group for kind of broader exposure and use. And then I would like to end with some acknowledgements. So thank you so much to the JNCC for the provision of the 2017 data, Dr. Vila Huven for the 2015 data provision, and then Ivan and Jamie both who did BIIGLE annotation of the litter that was within the Canyons MCZ, and then also some of the fauna that were in there as well. Thank you guys all so much. This project would not have been able to be completed without you. So I've got references, and then if anyone has any questions, I think I'm going to stop sharing, and I'll turn on my video for any questions.
Just firstly to say, Alice, that was so fantastic, such a good presentation. I'm sure everyone else also is in agreement on this. We do have a few questions to get through. I don't know if, let me know if you would prefer me to put the questions up on the screen, or I can just read them out.
Yeah, I think it's fine if you just read them.
Okay, we're going to start with a little bit of an easy one, just to get into a little more complicated ones later. But so in terms of naming your project, I've got one which is, it's really cool that you've named it this way. How did you arrive at this idea, and how long did it take?
Thank you. Yes. Yeah, I think it's hilarious that I was able to name it the Alice Project. It was a brainstorm. Took kind of, I don't know, probably a couple weeks of bouncing different ideas off, and they were all not so great. It was with my advisor, Dr. Jamie Davies, and my family a little bit. And then finally, once we hit the Alice Project, we thought we have to do that. So yeah, there was external help with that, but it was fun brainstorming.
Fantastic. I wish I could have something for my name that would work that way, but c'est la vie. So just going to start with the one on the litter categorization. So it was a question of, how did you define the litter categories? Did you use ICs or OSPAR or MSFD defined categories when breaking down your litter? So it can be linked to other research?
Yes, yeah, I didn't put that in this presentation, but yes, I did use the MSFD, the framework. So it's got, I think there are 6 or 7 different main categories, and then broken down into more specific categories. So plastic, miscellaneous, there's like metal, and yeah, different things like that. Mm-hmm.
Fantastic. So that's great for the framework. Yeah. Right. Which one next? So in terms of interactions with non-benthic species, there's a question on, did you see or find any information on those non-benthic species interactions with litter, such as with fish or marine mammals, during your review?
Yes, yeah, so I did find a lot, and most of the reporting is actually, it's the entanglement and ingestion, and it's with dolphins and seals and things like that. So the majority of what has been reported is non-benthic. I, for the purposes of the report, was focusing on just the benthic within the canyon, so that's not as detailed in here. But yes, the plethora of what people are seeing and able to report does occur with those non-benthic.
Did you see any any interactions when you were actually looking at the surveys themselves, or with non-benthic, or was it just because it was completely focused on the corals and everything like that?
Yeah, no, it was just benthic, because yeah, it was all like just filming the ground, so there wasn't really more to see.
Yeah. Brilliant, thank you. Right, next one up. Okay, so since June, this is probably with JNCC, since June, most of the Canyons MCZ has a ban on bottom fishing. Do you think that will have an effect on the litter presence, or do you think that most of the litter originates from further afield?
Yeah, I do think that that will have an impact just by the simple fact that it's right there. I think that there still will be some more coming in because the currents are bringing stuff thousands of kilometers away from where it originated. But yeah, I did hear about that ban, and that's really exciting. And I'd be interested in a couple years to check again and see what the impacts are. But yeah, I think it will have an impact. I think it probably won't end it all, but I think that is definitely helpful. And more of those bans worldwide would be awesome to see.
A little bit of a more fun question here. Playing devil's advocate, do you think marine litter can have any benefit to organisms, e.g. providing more habitats for the organisms?
Yeah, and this is a fun one because I read a lot about that as well. Different people arguing that this habitat provision is good, and then different people arguing that it's not. My general consensus is that any type of modification of a natural system is not good. So while more habitat can be produced, that potentially brings in more competition and just kind of changes the natural balances. So yeah, I think in general marine litter is not beneficial.
Yeah, yeah, completely agree with that. So going to ask about the sensitivity assessments now. How did you determine the sensitivity in your assessments? Did you refer to the MBA's Marcy method, or did you use a different method?
Yes, it was, yeah. Will you pronounce that again? Is it Marisa?
Marisa, sorry.
Yeah, no, I just wanted to be sure it was the same one. Yes, yeah, and if someone's interested in that specifically, I have like another document that's got a lot more information, and I have like each specific sensitivity level that was assessed. I have like reasons behind that. But yeah, so I was following that like standardized framework. And yeah, I think that answers the question, but yes.
Yeah. I don't know if the person who's asked the question is still on the call. If you are, like, raise your hand if you would be really interested in getting that document, or I'm sure we would be really interested in it because of course, its impact with the canyons itself. Yeah. Johnny, do you want it? You can speak if you want.
Yes, I'd be really interested in seeing that document for your sensitivity assessments.
Do you have any other questions, Johnny, specifically referring to that?
I'll send you an email afterwards, if that's all right, Alice.
Say that again?
I'll send you an email afterwards.
Yeah,
Great.
definitely.
Thanks so much.
Yeah.
Brilliant. Thank you. And then I've got one final question on that, unless anyone wants to fire any quick ones out after this. Do you think your findings of litter and the interactions between litter and organisms in the Canyon MCZ is representative of other submarine canyon environments?
Yes, and I think, well, so it differs whether it's coastal or whether it's offshore. So just the types of litter seen. A lot of time, the offshore ones will have more fishing gear, like I mentioned, and then the coastal ones will have, they can have cars and they can have fridges and different things like that. So potentially the types of interactions could change, based on location. But these different, I think the categories will remain consistent, especially because when I was coming up with those categories, I was looking at a plethora of reports from all over the place.
Brilliant. Thank you so much. I don't know if anyone wants to ask a question in person, and if so, like, you can raise your hand. But thank you so much. That was perfectly timed as well. And we will have the recording available if anyone wants to share or watch it further. But for now, thank you so much, Alice. A round of applause, I'm sure, is well deserved. And there we go. We can let you go about your day.
Thank you so much.